Lesson 5.5, Performing Function Operations. Our essential question, how do you add, subtract, multiply, and divide functions? There are 2 problems left for independent practice. Let's go ahead and take a closer look at those. So I am being given the f of x of 5 times the 4th root of x plus 1, and my g of x to be negative 3 times the 4th root of x minus 2. I'm asked to find a new function. So here's me splitting my paper. My new function, my f plus g function, says I'm supposed to take all of f and I'm supposed to add it to all of g. Find the entire f rule, which is right here. So I have my 5 times the 4th root of x plus 1. Here is all of g. And the rule said to add it to all of, that was all of f. The rule said to add it to all of g. So what is g? G is the negative 3 times the 4th root of x minus 2. So I'm now adding it to all of g. So what do I actually have? We already had 5 times the 4th root of x. So here's 5 times the 4th root of x. I already had an added 1. Now I'm supposed to add a negative 3 4th root of x. So here is my minus 3 times the 4th root of x. And I'm already supposed to add a minus 2. So here's my minus 2. 4th root of x's only go with 4th root of x's. So I had 5 of these 4th root of x's. And I'm supposed to be subtracting 3 of those 4th root of x's. So 5 minus 3 said I had 2 of these 4th root of x's. Constants only go with constants. 2 minus 1 minus 2 gives me a negative 1. So my new f plus g of x rule is 2 times the 4th root of x minus 1. Well, now I'm being asked to evaluate it when x is 1. So I have the f plus g of x rule where the x is supposed to be 1. So these x's are going to be replaced with 1s. Okay, so let's go ahead and evaluate. I have 2 times the 4th root of 1. The 4th root of 1 is 1, and we're supposed to subtract 1. 2 times 1 is 2. 2 minus 1 is 1. So f plus g at 1 gives me 1. So now let's go ahead and look at our domains. First, I need to look at the domain of f of x. Now, if I was just looking at the 4th root of x, we're going to put a little thought bubble right here. So the 4th root of x, if I was just graphing the 4th root of x, the 4th root of x kind of looks like this. Because I'm adding 1 on the outside, an outside added 1 said that this had to be moved up 1. The f rule was moved up 1. So my f function kind of ends up looking like this. Domain looks at the x values. I see this x value right here is still the last x value used. It doesn't go any further this direction. This x value is the x value of 0, and I use all the positive numbers. So I am still x is greater than or equal to 0. Let's go ahead and look at our other domain for g of x. It's still a 4th root, so it started off looking like this. The outside minus 2 tells me that I moved down 2. So my graph kind of looks like this now. Domains look at x values. This is the last x value used. He is an x value of 0. The function is going to use all of these positive x's. So we are still greater than or equal to 0. So now I need to look at the domain of my f plus g rule. What do these two have in common? F says use only positives. G also said only use positives. Only positives, only positives. What do they have in common? Only using the positives. And that is my domain. Our last problem, I'm going to go ahead and split this. On this side, I'm going to have my domains. And over here, I'm going to add. It's asking me to do my f plus g of x rule, which says I need to have my f of x and I need to add it to my g of x. So finding my f of x, this is my f of x rule, so that's what I'm going to start with. Negative 2 times x to the 2/3 power. And the rule is to add, so I'm adding the entire g rule. Where is my G rule? My G rule is right here. It is 7 plus the x to the 2/3. Sorry, the 7x to the 2/3. So here's my entire G rule. So what do I actually have? I started with a negative 2x to the 2/3. And now I'm adding this entire 7x to the 2/3. I am counting x to the 2/3. There were negative 2 of them, and now I'm adding 7 of them. Negative 2 plus 7 says I had 5 of them. So this is my f plus g of x rule. Well, now I'm being asked to evaluate this when x is 8. So my f plus g of x rule evaluated at the value of 8. My x's were all replaced with the 8's because we're evaluating at 8. So I end up having 5 times, I don't know 8 to the 2/3 power. I need to change it to the radical so I can see it. So this is the 3rd root of 8 all raised to the 2nd power. So I have 5 times, I know the 3rd root of 8 is 2. So this is now 2 squared, which is 4. So I have 5 times 4, which gives me 20. So the f plus g at 8 rule is 20. Now let's go ahead and look at our domains. First, I need to find the domain of f of x. If you were to graph the parent function of x to the 2/3, it would end up looking like this. Because we have no adding and subtracting on the inside, we're not moving left and right. Because there's no adding and subtracting on the outside, we're not moving up and down. So I know that I still have my parent function that's always to the left and always to the right, which meant my domain is still all real numbers for f. Let's go ahead and look at the domain for g. There's no adding and subtracting on the inside with dx, which means I am not moving left or right. There's no adding and subtracting on the outside, which means I'm not moving up or down, which means the parent function for g basically looks like this still, where it's always to the left and it's always to the right, which means my domain is still all real numbers. So now we need to look at the domain of our new f plus g rule. If f said I use everybody, and g said I used everybody, what do they have in common? Everybody. So my domain is all real numbers.